Today's lesson is on converting between standard form and vertex form. We started converting a little bit between vertex form and standard form a couple of days ago when we were graphing. This first example, number 1, is in vertex form because if we were to look at that, based on what you learned yesterday, you should be able to tell me the vertex. Who can tell me what the vertex of number 1 would be just by looking at it? Jonathan? -3, -10 would be the vertex. Okay, very good. So that's in vertex form because we can easily see the vertex. If we wanted to convert it to standard form, what we would do is we would write out, that's x plus 3, the quantity squared. That means x plus 3 times x plus 3. So we would write x plus 3 times x plus 3. And then we still have the -10. Okay, so that's a binomial times another binomial that you would need to multiply together. And so we're going to use the distributive property to take care of that. Okay, so here we go. If we do x, we're going to do x times x and then x times 3. So we have y equals, what's x times x? X squared, and x times 3? 3x. Okay, and then we're going to go to the 3 and we're going to distribute the 3. So 3 times x is 3x, and 3 times 3 is 9, and we have -10, right? Okay, so then we have y equals x squared. There are no other x squareds. We have a 3x plus a 3x, which would be a positive 6x, and then we have 9 minus 10, -1. That is now in standard form. So we went from vertex form all the way down to standard form. That's what that is. V for vertex down to standard form. That is very easy, okay? That's why I only have a couple of them. You know, depending on if you are asked to do that, you might need to do that. Vertex form is very helpful because you can immediately see the vertex, okay? Standard form, you know, for different reasons, you might want something in standard form. So that's how you would convert to standard form. If you look over at number 2, and I would ask that you please not start number 2 in class because, you know, if we finish early, you can work on it. But, whoa, oops. But number 2 looks just like number 1, okay? What am I doing? There we go. All right, let's go down to number 3. And we're going to work this one, and it is very similar, okay, except for we have that 2 out front. So we're going to write y equals 2, and then in parentheses, we're going to do x plus 1 times x plus 1. And then we still have that -7 out here. Now, at this point, you have a couple of options, because what you have right now is you have 2 times x plus 1 times x plus 1, and then -7. But we're not going to deal with that -7 for a little bit. So here's your options. You could multiply these 2 binomials together first, and then distribute the 2 throughout what you get, or you're welcome to do 2 times x plus 1, like 2 times x and 2 times 1, get that, and then take that binomial, multiply it by this binomial. And I don't know that either way is any easier. I mean, they're both easy. So anybody have a preference? Anybody want to choose what we do as a class here? What do you want to do, Isaiah?
Do add the things together and do 2.
You want to do multiply the 2 binomials together first?
Yes.
Okay. Probably because that's what we did in number 1, so you feel like you want to do that again, right? Mm-hmm. Okay, so leave the 2 out front, and in parentheses, let's multiply this out. X times x?
X squared.
X times 1?
X.
1 times x?
X.
1 times 1.
1.
Close your parenthesis, drop down the -7. Now, again, at this point, you could go ahead and distribute the 2, but I would probably, do you see something that you could do, Isaiah?
Add the 2 x's.
Yeah, this right here could be condensed a little bit better. So y equals 2, and then x squared plus, what's x plus x?
2x.
2x plus 1, close it, and then -7. Do you guys see why we did that? Just simplify that a little bit. Okay, now we're going to distribute the 2, but the 2 will not be distributed to that -7, all right? Only to the parentheses. So y equals
2x
2x squared
plus 4x plus 2.
And then
7.
minus 7. And then last step is just to combine anything that can be combined. So y equals,
2x squared plus 4x minus 5.
you guys agree with Cade?
Yes.
Okay, very good. Good job. And so you have gone from vertex form down to standard form again. Not difficult. A little bit of work there, but not difficult. Okay, you guys can handle that. Okay, now, the rest of the lesson is on going from standard form to vertex form. Why might it be beneficial to change the standard form into vertex form? Hannah.
Because then we can see where the vertex is already.
Exactly, because if we could convert this to vertex form, then without having to do the little negative b over 2a and making a table, we can see the vertex right away, can't we? Now, you're still going to have to do some work, okay? You're either going to do some work to see the vertex, once you have revised the equation, or you do the negative b over 2a method that we learned yesterday and the day before to get the vertex. Either way, okay? But one of your standards that you guys have to know is that you are able to convert an equation, a quadratic equation, that is in standard form to a quadratic equation that is in vertex form. So I'm thinking that maybe you would be given, your test is on the computer, that maybe at the end of the year, that maybe your question might have, I'm just thinking one way of assessing it, they may have, a question and they may have some steps and maybe you have to fill in a missing portion, to complete the process, if that makes any sense. So it might not be that you have to take this and write the new equation in vertex form, but you might have to fill in some of the steps along the way. Does that make sense? So really pay attention here. It's new, but it's not hard. Okay, so what we're going to do is we're going to start. Do you guys remember completing the square a little bit, or at least you remember what I'm talking about when I say completing the square? Okay, a little bit of that is what we're going to do today. We are going to complete the square, but we're not going to have to solve for the zeros like we did when we did the completing the square. That was a lot of work, okay? Okay, so we're going to write x squared plus 8x. We're going to leave a space, and then we're going to put the minus 1 over here. Okay, then what we're going to do is we are going to do b over 2, and then we're going to square it. So b is 8, so we're going to do 8 divided by 2, and we're going to square that. What's 8 divided by 2?
4.
4 squared is 16. So what you're going to do is you are going to write plus 16 minus 16. Okay, now let me explain something. By putting plus 16 minus 16, we haven't actually added or subtracted anything to that side of that equation, correct? Because 16 minus 16 is 0, right? Okay, so we haven't really done anything. We've added visually we've added things in there, but as far as amount, we haven't added anything or subtracted anything. Now, at this point, what I want you to do is I want you to do a little half box around this trinomial right here. Your A, B, C, x squared plus 8x plus 16. And then I want you to circle any numbers that are left out there. Okay, so now we're going to write y equals. Now, the whole completing the square concept is so that you can, by coming up with this 16, we can now factor this trinomial right here into a perfect square, meaning like x plus 2 times x plus 2, or x plus 7 times x plus 7, or x minus 8 times x minus 8. Two parentheses that are identical, okay? So, and remember, if we have two parentheses that are identical, we only write it once with the squared outside the parenthesis, like x minus 1, the quantity squared, okay? All right, so make a parenthesis with a little squared out here. And let me remind you of what to do here. All you're going to do is, what is the square root of x squared?
X.
Just x, good. What is the square root of 16?
4.
4. And then this sign right here is the sign that goes in the middle there. That plus sign. If it was a minus in front of the 8, you'd put a minus there. Okay, that's pretty easy, right? Now let me just say this. Do you remember when we factored how we had to look for two numbers that multiplied to make 16 but added up to make positive 8? So 4 times 4 is 16, and 4 plus 4 is 8.
Yes.
So that's why we would have had x plus 4 and x plus 4. Right? X plus 4 times x plus 4. Two separate parentheses, but when they're the same, we write 1 with a little squared outside. Okay? Now, if you ever want to double check yourself, do what we did a little bit ago in number 1 and write it out. X plus 4 times x plus 4, and do your distribution there, and you'll see that you get x squared plus 8x plus 16. Okay? All right, now, the last thing you want to do is this right here. What would this calculate to be?
-17.
Now, look at this answer that you have right here. Does that not look like it is in vertex form? What would the vertex of that quadratic be?
-4, -17.
-4, -17. That really isn't all that hard. Yeah, so we went from standard form, if you're writing these out to the side, down to vertex form. Standard down to vertex form. Okay, now number 6 is going to be just like number 5. You're going to do that one at home. Okay, let's look at number 7. All right, we're going to do the same thing. So we need to write this in vertex form. So we're going to have x squared plus 10x, and then typically we leave a space and write that other number, which is our c, right? Our c is the one that has no variable, but we don't have one, so that's okay. Now we're going to go do that next step, which says to do b divided by 2 squared. So what's my b? 10. So I'm going to have 10 divided by 2, and I'm going to square it. So that's 5 squared, which is 25. So I'm going to go up here by my 10x, and I'm going to write what?
Plus 25.
Yes, good. Then I'm going to do a little half box around my trinomial. Yes?
Yes.
And I'm going to circle just -25. I don't have another number out there that's going to have to combine with it. So this one actually is less work. You guys see that? Okay, so now we're going to write y equals, we know that this is going to be a perfect square because that's the whole point of doing b divided by 2 square is so that it comes out to a perfect square. What's going to go in the parentheses?
X plus 5
squared.
minus 25.
There you go.
That's easy. Easy.
Okay, they get a little bit more complicated. What was my a for both number 5 and 7?
1.
A was 1. When a is not 1, it gets a little more complicated. Like number 9. Yay! Now listen, it's okay, but you're going to have to really pay attention here, okay? All right, if you happen to recall, and I feel like it's been forever ago since we did completing the square, day 2 of completing the square, we had to get rid of our a. We had to go through and divide everything by whatever a was because we wanted a to be 1 in order to do our completing the square, right? Do you remember that much at least? Okay, so here's what we're going to do. We're going to go and we're going to divide everything by whatever a is. So we're going to write y equals. Now, if we're dividing by 3, that means we're factoring out a 3. It's not going away. It's coming, it's like the GCF. It comes out front of your parenthesis, okay? So then we're left with x squared minus 2x. Typically, we leave a space here, right? Okay? And then out here to the side, we have plus whatever 8 divided by 3 is. Now stop. Do not put a decimal if it's not a terminating decimal. An 8/3, anything divided by 3 is never going to terminate. It's going to be 0.333 or 0.666, right? You know that, right? 1/3 and 2/3. Okay? So we're going to just leave this right now as 8/3. It's okay. Okay? Leave it like that. So now here's another very, very important piece of information. You know that in order to fill this little space in, that we do b divided by 2 squared. But do not go up here to the original b. Okay? Because, again, we're going to factor this right here, aren't we?
Yes.
We've pulled that 3 out, so now our b is 2. Really, our b is -2. But let me say something real quick. If we're going to do b divided by 2 and then we're going to square it, it doesn't matter if b is positive or negative, because when you square it, it's going to be positive every time. So you don't even have to worry about that. So our b is 2. So we're going to do 2 divided by 2, and we're going to square that, which is 1 squared, which is 1. So in our little blank there, we're going to put
+1 minus 1.
there you go. Okay? Now, do what we've been doing. Do your little half box around the trinomial and circle this part right here. So far, it's pretty much the same. We had to divide out that 3, and we've got that 3 out front, which we're going to have to deal with in a minute. But it's not that bad. Okay, now, here's where it gets a little so listen to me carefully. All right. You know that this trinomial right here, we are going to factor that into a perfect square. And when we do, it requires us to create a parenthesis, correct? So now we're going to have a parenthesis inside this other parenthesis. So instead of having a parenthesis inside of a parenthesis, we're going to make this out here be brackets. Okay? So leave the 3 and make a bracket out here. It just makes it look better. Okay? It's still the same concept. It's just like a parenthesis. It doesn't really mean anything different. All right, now factor what I have in blue there boxed in. X what? Minus 1 quantity squared, right? Because the square root of x squared is x. The square root of 1 is 1. And then this is the sign right here that comes down right here. Everybody with me? Okay, but then we got to deal with this. Now, it's not that bad. I would think of 8/3 as 2 2/3. That's how I would think of it, right? So then in my head, you should be able to, in your head, calculate a -1 plus 2 2/3 means I'm taking 1 away from 2 2/3.
So
1 2/3, right? Okay, so 1 2/3 is the same thing as, put it back into an improper fraction.
1, 2,
5/3, yes. 1 2/3 is the same thing as 5/3. So plus 5/3. Now, some kids would say, okay, I'm done. The vertex is +1, +5/3. It's not, because we got that 3 out front there. Now, this is where part of this, too, can be a little tricky. And really, you can see there's not a lot of work necessarily. It's a lot of comprehension. Okay, so watch what's going to happen up here. So this 3 out front is, because of the brackets, it's saying that this 3 is being multiplied by everything in here, correct? So this is 3 times this x minus 1 squared and 3 times this 5/3. It's like the distributive property. We got to distribute that 3 back in. So we're going to write 3 times x minus 1, the quantity squared, which we're just going to put it right there beside it, right? Because if we try to multiply it all out, we're going to be right back to standard form, aren't we? But we don't want to do that. Plus 3 times 5/3. Now, if you're like, what? Do it. Just come out here to the side. It's not that hard. 3 times 5/3 is like this. What am I doing? I heard Jonathan say 15 and it threw me. There we go. I know. Because 3 times 5 is 15 and 1 times 3 is 3. Okay, so you could get 15/3, which is 5, or you could simplify this, right? And you're left with 5. So either way, you're left with 5. And that is so much nicer looking. What would the vertex be for that?
1,
1,5. Now let me make this clear. It is possible to have a vertex with a y-coordinate that is a decimal or a fraction. That's possible. My point is, we still had this 3 out here that's supposed to be being multiplied by that, so you need to distribute that in. That's as hard as it's going to get right there. Okay? All right, so let's do number 11 together. What's A in number 11?
-1.
So what do you guys think we might need to do here? Divide by -1 all the way through, because it's got to be a positive one, right? Okay, so y equals, put that -1 out front, or you know what we could just do? Just put the negative out there. That's nice, and it's cleaner looking, okay? All right, so we're left with x squared, x squared, then what?
Minus 6x.
Minus 6x, leave a space, minus 4. Okay, now, filling in that space, we look right here, don't we? Okay, so we're going to do 6 divided by 2, and we're going to square it. So that would be 9. So we write, there you go. Then we're going to half box in our trinomial and circle that. So we're left with y equals negative. Now what? We do have to open up a bracket here because we're about to have a parenthesis inside a parenthesis. X minus 3, the quantity, squared. Keep going.
Minus 13.
Minus 9 and 4 would be minus 13. Close your bracket. Are there any questions so far? We still have one more step, right? We got to distribute that negative back in. Or that -1 if you want to think of it as a -1. So when we do, we have y equals negative x minus 3, the quantity squared, then what?
Plus 13.
Because see, it's going here and it's going here. So it is going to be plus 13. Because the -1 and the -13 is going to make a positive 13. What is that parabola going to look like? It's going to be hanging upside down. It's going to be sad. Real sad. Poor parabola.
It's because it's not Friday.
Okay. It's sad because it's only Thursday. All right. If anybody's watching this video in 2 more years, I don't know what day it'll be. But you know, like sometimes I have you guys watch one from last year. Who knows what I've said. I've tried to be funny on some of those, and I'm not funny at all. All right, 13 and 14 is exactly like 5 and 6. I just threw a couple extra ones in there. So we're not going to do 13 together, but you're going to do it at home. Any problems that we do not do in class, you have to do for homework. Okay, last page. We're going to do 2 of them on the last page. Okay, here we go. The directions say to convert the quadratic from standard form to vertex form and then graph. So here we go. Y equals, A is 1. So we can go ahead and just write x squared minus 6x, leave a blank, and put plus 7, right? We should go ahead and get started. We just take the A and the B terms, and we put the C term, the term with the C out to the side. All right, then B divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So we're going to put plus 9 minus 9. Then we're going to box in my trinomial and circle those 2. So y equals, parentheses,
X minus 3, quantity squared minus 2.
there you go. Pretty, huh? That looks good. That looks real good. Okay, I know. I'm such a math nerd. I'm like, woohoo, it turned out great. I'm so excited. I was super excited that my professional development that I was in during my lunchtime a little bit ago, some of the questions, we were talking about DOK level questions, and some of them were math related about like functions, and I'm like, oh yeah. Oh yeah. And I'm sure the other teachers were like, that's how I would feel probably if it was something else. But I could relate to it. I'm like, oh, I know the answer to this question. They're like, we're not trying to answer the question. We're just talking about the DOK level. Okay, so what's the vertex? 3, -2. Okay, so go to your graph and go to positive 3, -2, plot it, and then what?
Then you can go like
Up one,
up 1, up 3, over 1.
Very good. Do you know what comes after the up 3, out 1? Has anybody figured that out?
6.
I know. And then it's up
9.
over 1, up 5.
Up 5, out 1. So from there, up 1, 2, 3, 4, 5, and out 1. So if you wanted to do another set, you could, but you certainly don't have to, but you could. That's as far as we're going to go right now.
Wait, so we have
There. No, you can just do the 5 points if you want.
You know what? Just because
Okay.
we wrote it to each
You know, since it's on video, I don't make a mistake. Then I can't reuse my video. I'm just kidding. I could put a, what is it called, like a disclaimer, like Miss Wilson had a moment and she messed up.
Yeah.
Video, here, take 2. Okay, let's go to number 17. All right, okay, thoughts on this one? Right, we got to get that negative divided out or factored out. So we have y equals, and we can just put a negative, right? And then we're going to have x squared minus 4x, right? Because it's a positive divided by a negative.
Plus 4 minus 4 plus.
Whoa, whoa, whoa. Whoa.
You leave this kind of stuff in.
Okay, so when we factor out the negative 1, negative x squared divided by negative 1 is x squared. 4 divided by negative 1 is negative 4x. Leave a space, and then a negative 1 divided by negative 1 is a positive 1. Now, to fill in this blank right here, we look here, and we do b divided by 2 squared, which would be 4. So we do plus 4 minus 4. Good, Jackson. Okay, then we box in. Okay, who was that? I'm sorry, Chance. Y'all must sound very similar because I think I've done that before. I'm so sorry, Chance. I should give credit where credit's due. All right, and then we add those two together. Okay, so we have y equals negative bracket, parenthesis, x minus 2, the quantity squared, minus 3, close bracket. Now let me stop for a minute. Is there anybody, you need to just speak up, that says, I'm not understanding how you're getting the x minus 2? Because I need to know that. Okay, just as a recap, you're doing square root of x squared, it's always going to be x. The square root of this number, which in this case is 2, and then this sign right here is the one that always comes down. Are we okay with that?
Yeah.
Okay, now we got to do what?
Put the negative back in.
I hope when you answer short response questions, you don't say, just do that thing.
We do the
What? The mathematical term for the negative that is in front would be to do the distributive property, right? Okay, so we have, y'all are scaring me. Negative. I know, it's not though. It's just not Friday yet, guys. And then what? Plus 3. Thank you, Anna. Okay. And what's my vertex?
Positive 2, yeah.
Okay, so go positive 2 and positive 3.
And go down.
Why is it plus 3?
Because it's a positive 3 because, hey, wait. Jonathan was trying to explain it, but I'm going to wait for everybody to stop talking. Guys, remember, we are on a video, so if you were having to watch this at home, you would probably be a little bit frustrated if there was a lot of talking in the background. Right? All right, so when we have this negative out here, this negative is out front and is being distributed to everything in the bracket. So we distribute it to the x minus 2 quantity squared, and it has to be distributed to this minus 3, which turns it to a plus 3. Okay, so that's where we get the 2, 3. So then you plot that point, 2, 3. But then, what do you guys know? Yeah, because out front, because of this negative out here, it means it's a sad face parabola. It's very sad. He's sad because it's not Friday. So, so we go down and out 1 and down 3 and out 1. If you want to go more, down 5 and out 1. Okay, I'm going to stop right there, but you can continue if you want. All right, so any other problems that we did not do, you are responsible for.
Okay.